Hello, welcome to today's session, which happens to be the third session of consumer choice theory. So today we will look at the law of equi-marginal utility, and this is also under cardinal utility. So in looking at that, we start the theory of the marginal utility of money, where we will state the law. This law will be used to determine the consumer equilibrium under cardinal utility. So the law states that to obtain the greatest utility, the consumer should allocate money income so that the last quarter spent on each good or service yields the same marginal utility. Now, in the previous video or session, we mentioned that since the consumer will have to spend to equate the marginal utility or last quarter spent on each good, it means that for equilibrium to hold, the marginal utility of monies must be equal. In this case, so we will focus much on the law of equi-marginal utility and then build on to consumer equilibrium. Okay, so now assume two goods, X and Y, on which a consumer has to spend his given income. Now the consumer's behavior will be governed by two things. In this case, number one, the marginal utility of the goods, and secondly, the prices of the goods. Because for us to get the equal marginal utilities, we divide the marginal utility of the good divided by the price. So meaning these two will be enough to govern the determination of consumer equilibrium. Now, since the consumer will maximize utility if the marginal utilities of money expenditure is the same for all goods, it means that we can formulate the equation as follows, that the marginal utility of money must be equal to the marginal utility of X divided by the price of X, and this should also equal the marginal utility of Y divided by the price of Y. If we had more goods here, maybe good Z, good K, we would have still equated this to the marginal utility of any other good that we may bring in. Let's say the marginal utility of good Z. Okay, marginal utility of good Z, meaning we divide this by the price of good Z. So whatever amount of commodities we have or different types, we keep adding to this equation. Okay, so now if given this, we can define the terms that we have in this equation. Number one is that the MUM is the marginal utility of money expenditure. So what we have is that this part here is the marginal utility of money expenditure. Okay, and then the other one is the MUX, this part here, which happens to be the marginal utility of good X. The PX is the price of good X, the MUY is the marginal utility of good Y, and the PY is the price of good Y. So once we have all these information, these details, it will be easier for us to determine consumer equilibrium. Let's take an example. Consider two goods, X and Y, and suppose that the price of X is 1 kwacha, the price of Y is 2 kwacha, and the consumer's income is 10 kwacha. Now, we need more information for us to be able to determine consumer equilibrium. That is, we need details on consumers' utility levels. So let's see the utility levels in this table. So what we have is that for the quantities of good X ranging from 0 all the way to 7, we have the associated total utility levels for good X. And for the quantities of good Y ranging from 0 all the way to 7, we have the total utility levels for good Y. Now note that sometimes you may not be given the quantity of X and quantity of Y separated like this. All you may be given is just the quantity, and this quantity may refer to both X and Y. In this case, it means you will only have 3 columns. That is the column for quantity, the column for the total utility of X, and the column for the total utility of Y. there will be no distinction, say this is quantity of x, this is quantity of y. All you will know is at 0, x is 0 and y is 0. At 1, x is 0 and y is, x is 1 and y is 1. At 2, x is 2 and y is 2, and so on. So that should not confuse you at all. Okay, so now given these total utilities, what we need to do is to get the marginal utilities for the table. So the question is, find the amount of x and y that maximize utility, and then what will be the total utility obtained at those units. So with the marginal utilities that we have is that we will equate this equation, this marginal utility of money, to the ratio of marginal utilities to price. With that, then we can compute our marginal utilities as follows. So this column here gives us the marginal utility of good x. So at the quantity of 0, total utility is 0, meaning marginal utility will be 0. Now recall the computation of marginal utilities from our previous session. At a quantity of 1, total utility is 10, marginal utility will be 10. At a quantity of 2, total utility of x will be 18, and therefore marginal utility of x will be 8. So recall that we get this marginal utility by subtracting total utility 2 minus total utility 1 divided by quantity 2 minus quantity 1. So 18 minus 10 divided by 2 minus 1, and this should give us our marginal utility. So we do the same for all these quantities. So at the last 7th unit here, marginal utility will be 43 minus 40 divided by 7 minus 6, and that will give us a 3. This is for good x. If you go to good y, we also have the quantity of y and total utility of y. Marginal utility at the 0 quantity of y is undefined. Then marginal utility at the first unit, we have 24 because total utility is 24. So we subtract 24 minus 0 divided by 1 minus 0. Then for the second unit, our total utility is 44, meaning our marginal utility will be 44 minus 24 divided by 2 minus 3, and we'll get a marginal utility of 20. For the third unit, total utility is 62, meaning that for us to get marginal utility, we subtract 62 minus 44 divided by 3 minus 2, and we'll get 18. So we do the same for all these quantities, and we'll see these marginal utility levels. Now recall that consumer equilibrium is not only determined by the marginal utilities. We said it is determined by the marginal utilities as well as the price levels. And according to the law of equimarginal utility, equilibrium in this case will be the ratio of marginal utility of x divided by the price of x. Pardon my drawing. This should be equal to the marginal utility of good y divided by the price of y. So if we find this level, it means that we will have found our consumer equilibrium. Now to do that, so we've added a new column here where we are finding the ratio of marginal utility of x to price and the marginal utility of y to price of y. Now price of x has been, from the example we have, is at 1, while price of y is at 2. So in this case, since the price of x is 1, it means that we'll be dividing the marginal utilities divided by 1. So at the 0 quantity, which is undefined, the ratio will be undefined. For the marginal utility level of 10 divided by the price of 1, we will get the 10. 8 divided by 1, we will get 8. 7 divided by 1, we will get 7, and so on until we reach the end where we are dividing the marginal utility of 3 divided by 1 to get 3. When we come to good y, the price of good y was set at 2 in our example, meaning that for us to get this ratio, we will be dividing the marginal utility divided by 2 for each level. So at the quantity of 0, marginal utility is undefined, so we divide this undefined divided by 2, we will still get undefined. 24 divided by 2, we will get 12. 20 divided by 2, we get 10. 18 divided by 2, we get 9, and so on until we reach 4 and divide it by 2. Now that we have our ratio of marginal utilities to price for both X and Y, we can now determine our consumer equilibrium. Now, for equilibrium to exist, the value obtained here and the value obtained here must be equal. So for a student, it would be nice for you to start checking what value do we have here that also exists here. So clearly you will see that we have 10 here and we also have 10 here. We have 8 here and we have 8 here. We have 6 here, we have 6 here. And then these are the 3 points of equilibrium. Actually, we also have 3 here and we have 3 here, meaning these are the 4 points of equilibrium that we have from this table. But the question is, are all these 4 points the points of equilibrium? To do that, you need to note that for a consumer with a given budget, the goal is to maximize the utility subject to that budget. Meaning we will have the budget line equation, which is the price of X multiplied by X plus the price of Y multiplied by commodity Y, and this must be equal to the money income of a consumer. Let's call it I. So in our example, income has been put at 10. The price of X is 1. The price of Y is 2. So when we get the quantities here and multiply by the prices, we should get the money income of 10. So in this case, allow me to work it out from here. So in this case, or let me remove this and start a new one. So in this case, what we have then is that from this equation, price of X multiplied by X plus the price of Y multiplied by Y must be equal to the income, which is I. So now we know that the price of X is 1. We know that the price of Y is 2. And we know that the money income is 10. What we don't know is the quantity of X that we should put here and the quantity of Y that we should put here, such that when we simplify this equation, it should give us a 10. In other words, we need to find the value of X and Y that makes the equation equal to 10. So let's begin by looking at the values that we have here for marginal utility of money. At the marginal utility of money, the ratio of marginal utility of X to price of X for commodity X at the value of 10, we see that quantity consumed will be 1. For Y, at this ratio of at the value of 10, quantity consumed will be 2. So if I put a 1 here and I put a 2 here, clearly you will see that this equation, these numbers will not equal 10. In other words, the value you get here will be 5, and that 5 will be less than 10. So you move on to the next value, which equates to that of Y. So here we see that we have 8 here and we have 8 here. Now, from these values, we can put at the value of marginal utility ratio to price of 8, quantity of X consumed is 2, whereas for Y, quantity of Y consumed is 4. So meaning, if I add my 1 multiplied by 2 here, plus 2 multiplied by 4 here, wow, this gives me 10. So therefore, it shows that this value here already qualifies to be the consumer's equilibrium. We can do the testing also for the level of 6. So we see that at the ratio of 6, the quantity of X consumed is 4 and the quantity of Y consumed is 5. But already, if I put 5 here, this value will be 10. And if I put 4 here, this part here will be 4, meaning the total will be 14. If I got the last value, which is 3, X consumed will be 7 and Y consumed will be 6. If I put 6 here, this will be 12. If I put 7 here, this will be 7, and the total will be 19. Therefore, we can conclude that in this case, consumer's equilibrium occurs where the ratio of the marginal utility of X to its price is 8, and the ratio of the marginal utility of Y to its price is 8. And corresponding to these ratios, the quantity of X consumed is 2, and the quantity of Y consumed is 4. So with this, we can finish up our analysis. So thus, 2 units of good X and 4 units of Y are consumed because the ratio of marginal utility of X to the price of X equals the ratio of marginal utility of Y to the price of Y, which is equal to 8. The second question was, I was asking us to find the total utility at these levels or these units consumed. Now, if you look at the previous table, the table that we just computed, so at the unit of 2 of X, total utility is 18. So meaning we will have 18 here, and then we'll add from the Y side, Y consumed is 4 and total utility is 78. When we add these two, we get total utility to be 96. And this is picked from our assumption 2 that utilities are independent, so meaning they are additive. Okay, so then we are saying total utility at those units is 96 because we have 18 utils from X and 78 utils from Y. Let's look at example 2. Consider example 1. Now suppose that the price of Y reduces to 1, other things equal, meaning the price of good X remains at 1 and the price, the income level remains at 10. What amount of X and Y maximize utility? And then we are asked to derive the demand curve for Y. Now with this, recall this table that we had. This column is for the quantity of X consumed. This column is for the total utility of X. This column is for the quantity of Y consumed. And this column is for the total utility of Y. With that, utility will be maximized if the marginal utility of money is equal to the ratio of the marginal utility of X to its own price, also equal to the marginal utility of Y to the price of Y. So we had computed this table. So these are the marginal utilities that we got, and these are the corresponding marginal utility price ratios. So I'm sure you are now familiar with how we are getting these values, the marginal utilities, as well as the marginal utility to price ratio. So here, now that price has reduced for Y, price has gone to 1, it means that we will be dividing the marginal utility of Y divided by 1. So for the level of 24, the ratio will be 24. For marginal utility of 20, the ratio will be 20 because we are dividing 20 divided by 1. So, and if we do that for all these values, we will have these corresponding ratios. Now note that nothing has changed from the X side because the price of X has not changed. Therefore, these ratios still remain as they were in the previous table. Now, in determining consumer equilibrium, we said we are supposed to look at the ratios which will be equal from both the X side and the Y side. So if we do that, we start going through, we will notice that we have a 6 here, which is also equal to the 6 we have here. And then we have a 4 here, and we have a 4 here. So in this case, we only have 2 points that we will be comparing. So our equation, again, remains that we are looking at, okay, let me draw this for you. So we'll be looking at the equation price of X multiplied by X plus the price of Y multiplied by Y, and this must be equal to the money income. Now, price of X is 1, price of Y is 1, we've reduced it to 1, and the money income is 10. So what we are looking for then is the amount of X consumed and the amount of Y consumed that will make this side equal to 10. So we have 2 points. We have the ratio of 6 and the ratio of 4, which is equal in both sides. So here we have 6 and 4, here we have 6 and 4. So for 6, when the marginal utility ratio to price equals 6, it means we are seeing that X consumed will be 4. Okay, and Y consumed at this level will be 6. So we put 6 here. So if we multiply this and then we multiply this and add, we see that this side will be 4 plus 6, which will be equal to 10. Meaning already we've seen that the ratio of 6 gives us the optimal values. Before we make a conclusion, let's also test at the ratio of 4. Now at the ratio of 4, we have X consumed will be 6 plus 1, and Y consumed will be 7. Now when you add 6 plus 7, you end up with 13, which will be greater than 10. And therefore, this ratio here will not give us consumer's equilibrium. With this then, we can conclude therefore that the consumer's equilibrium occurs at the ratio of 6, where the quantity of X of 4 is consumed and 6 of Y is consumed. Let's do the analysis on this page. So thus 4 units of good X and 6 units of good Y will maximize the utility. Why? Because the marginal utility to price ratios are equal at the level of 6. Note that total utility has increased to 127 utils because we have 31 utils from X and 96 utils from Y. So we can confirm that those are the values. So here we have 31 of X. This is the total utility from X, and we have 96 from Y. So when we add these two, we end up with 127 utils. Okay. Now, needed is for us to now draw the graph. So on the vertical axis, for the first one, we draw the ratio of marginal utility of Y to price of Y. So we want to derive the demand curve for good Y. And on the horizontal axis, we put the quantity consumed. Now, we made an assumption that the marginal utility of money is constant, and therefore the line will be horizontal. With that, marginal utility of money is assumed to be constant under cardinal utility. And then we notice that the marginal utility to price ratio was dropping as much as the consumer was taking in more of a given quantity, whether from X or from Y, which means the graph will be downward sloping. Now, when the price, this is at the price of 4, so a reduction in price increases the purchasing power of a consumer, meaning the consumer will be able to buy more of a given commodity. So in the first example, we saw that only 4 units of X were consumed, but in the second example, after reducing the price to 1, 6 units of X of Y was consumed. So with a reduction in price, then the ratio curve shifts to the right. Okay, and we see that 6 of good Y will be consumed. Corresponding to this is the demand curve, where we plot the price on the vertical axis and the quantity on the horizontal axis. So at the price of 2, when good Y was priced at 2, a consumer consumed 4 units, and when the price was reduced to 1, 6 units were consumed. Joining these points gives us the demand curve for good Y. So since price has reduced from 2 to 1 per unit, quantity demanded of good Y increases from 4 units to 6 units. So we see that there's a movement down in reduction of price and then quantity increasing. So thank you very much for watching. If you have questions, please send an email to moawelias@gmail.com. I will share with you the YouTube link where you can find this video and be able to watch at your free time. Thank you.